This video is about simulations. The definition of a simulation is that it's imitation of a process or system, often through a computer program, to study its behavior, functioning, or performance under different conditions. So in this definition, you will see there are a few components. So the first one, what is a simulation? So we say that a simulation is basically an imitation of a real life system. So which means there's a real life system, they are working, and we want to do their imitation while sitting in our office, and you want to do it using through a computer program, and that computer program could be Microsoft Excel, it could be R Studio, it could be Python, it could be any other program, but it will essentially be carried out through some computer program. And the objective of simulation is that we want to study the behavior of a system. And why we want to study the behavior of the system? Because we want to improve that system, and improving that system, it requires that we do some simulation, because studying that behavior in real life would be very expensive or very risky, or so we want to study its behavior, functioning, or performance under different functions. So that is the whole idea for simulation. Again, these are three key components of a simulation: imitation using some computer program, and the objective is this one. Now I would like to give you an example. You may be familiar with that on January 15, 2009, an incident happened. The incident that had never happened in the history of aviation. One airplane of US Airways, it took off from LaGuardia Airport, and just after taking off, after maybe I think a few minutes, 9 or 10 minutes, there was an accident. And again, the accident was a very different type of accident, in the sense there was some birds hit into the engine of the plane and they destroyed the engine. And when I'm talking about the birds, I'm not referring to a hummingbird, I'm referring to Canadian goose. And these birds, they are big, and a flock of those birds, it was flying, and they hit into engines. And just to keep things in perspective, this Canadian goose, an adult bird, it can weigh up to 15 or sometime 20 pounds, so it's really big. And when they are flying, the span of their wings is also quite broad. So although it seems a little bit counterintuitive, but the fact is that these birds, they do affect engines. So it hit the engines, and engine lost its thrust. And then a captain of the plane, the name of the captain was Captain Sullenberger. So he made a decision. Again, the decision was very different decision, because that type of decision had never been made earlier in the history of aviation. So the captain decided to land the plane in River Hudson, and afterwards Captain Sullenberger became a hero, and he was everywhere in news. And there were many movies were made, and I remember one of the movie was Tom Hanks played the role of captain. He was everywhere as a hero, but airline was a little bit skeptical, maybe because they had lost a plane of several $1 million. So they were wondering, was this landing in Hudson River, was it really necessary, or just captain did unnecessary heroism? Now question is that how would they know? They cannot fly another plane to see if the same behavior would be replicated next time. That's not possible. That would be very costly, that would be very risky. So the only option they had to assess whether it was really needed or not, to do simulations. And then they did simulations, experiment on their computers, that okay, what would happen? These are the parameters. So one of the parameters is that what was the height of the plane, and other parameter was that how much was the weight of the plane. The third parameter was that how close the airport was. In any case, they conducted several simulations, and then they concluded that captain had no option except to land on the Hudson River. So in this case, simulations helped to make a decision that was otherwise impossible. So simulations, they have application in many other disciplines. So for instance, if you want to make some big investment, people make simulations. When future customer demand is unknown, then simulations are done. If you want to open a restaurant, you will do simulations. You want to calculate how much risk, again you will do simulations. Now I remember one of my student, he wanted to open his own cafe, and then he conducted these simulations. So he was conducting about different alternatives. One of alternative was that was very cost effective to him. He wanted to open a portable type of setup in his RV, whereby he would just drive to a place where some events are happening and he would start selling his products. That was one alternative. Second alternative was he would lease a shop, a small shop on some main street. And the third option he was contemplating was to open his cafe in a big mall. That would be expensive because leasing cost would be very high. So he conducted this experiment, which means he estimated what will be the customer demand, what will be my cost, and then based on all these factors, he did simulations and then he made his decision. Now these simulations, they have applications in financial institutions. So for example, consider those big financial institutions like BlackRock, Citadel, JP Morgan, Fidelity, Vanguard. In their case, there are many factors that are unknown. I mean, market is very volatile and you don't know what's going to happen next. So in order to make decisions, they do simulations. And then in entrepreneurship, whenever you want to take some new decisions, or you want to use some existing technologies and you want to put them to new application, again you will use simulations. Strategy development, and in aviation again, and oil refineries where you want to a certain risk, you do all these simulations. Now I will explain how to do simulations using Microsoft Excel. And before that, I will start with some basic commands that are used in simulations. So it's important that you learn these. The first one is a random number, which means how to generate a random number using Microsoft Excel. And for this one, the command is rand and then parentheses open and close, and if I hit enter, it should generate a random number. So this is random number, and accordingly I can drag it down. So all these are random numbers generated by Excel. Now one of the thing about these random numbers is that they keep changing. For instance, you see, if I write here any number, let's say 5, and I hit enter, they are changing. Similarly, if I keep writing here number, they will keep changing. So that's a property of Microsoft Excel, that they will keep changing. And other thing is rand between, which means we want to generate a random number between two specified numbers. So for instance, if I want to generate random numbers between 10 and 15, I will use this command, rand between 10 and 15. Now this will generate random numbers that will be between 10 and 15. Nothing less than 10, not more than 15. And if I drag it down, you can see here, they're all between 10 and 15. Then the next thing is about normal distribution. Many times we have been given some variable that have normal distribution. For example, demand usually follows normal distribution. Age of people in a large population follows normal distribution. So in normal distribution, we need three things. One is probability, and mean, and standard deviation. And usually mean and standard deviation are given. And to calculate probability, we use this formula, that's norm inverse and then probability. Now probability is usually not given, and we need to generate it using this rand number. And for that, I will just write here rand and then parentheses open and close, and then as you can see here, it says mean and standard deviation. Now I will write here the value of mean and standard deviation. That will be a numerical value. Let's say, for instance, if I say mean is 10 and standard deviation is 2, and if I hit it, it will give me some probability. So this is the formula for generating probability. And again, because it is using rand function, and rand numbers, they are automatically generated, they keep changing, it means that will also change, your answer will also change accordingly. Okay, so in this simulation, here is a problem, and the problem is that as the owner of a small clothes stitching company, you grapple with fluctuating demand for pullovers, which significantly impacts your cost. These costs encompass the expenses associated with tailors. So they have a number of tailors. In this case, they have up to 6 or 7 tailors, overhead, material cost, and overall planning. So all these things are affected. Among these, the cost of tailors stands out as the major factor, necessitating a crucial decision regarding the optimal number of tailors to employ. However, due to the varying demand and the normally distributed nature of material cost, conventional cost profit models prove inadequate, and therefore you have to do simulations. So this is the data that we have, and again, as you can see here, that in any company, one thing will be material cost. That will be one of the important factors that affect your cost. So material cost per jacket, it's normally distributed, its mean is $12, which means the cost of one jacket is $12, and its standard deviation of this cost is 1.37. Weekly production rate, it varies from 31 to 41, which means we'll be using rand between function to find out one. And then weekly wages per tailor, that's $700, which is a big cost, it will affect your revenues. And then weekly overhead cost is also $800, which is also a big chunk. And then selling price is $50. Now we have all this data, and we have to do simulation. Now the question arises, can we do a simple calculation whereby we can say, okay, this is my revenue, and from revenue I deduct, subtract these costs, and it should give me my profit. Well, you can do that, but they are not sufficient, because all these things, they are not constant. So for example, weekly demand, it varies, and material cost, again, it also varies, weekly production rate, it also varies. So in this case, our traditional models, cost profit model, they may not be very much suitable, and therefore we will have to do simulations. And for this purpose, we'll be doing 100 simulations. And by simulation, it means that we will be conducting 100 experiments using different combinations of probability values, and then we will see what happens. So currently they have 6 tailors, and they want to determine appropriate staffing level, which means how many tailors they should have. 1 tailor, 2, 3, 4, 5, 6, how many? And again, of course, it depends on a number of factors, and all of these factors are, they are not constant. So weekly demand keeps changing, material cost keeps changing, weekly production rate, it keeps changing. So therefore the best strategy in this case is to conduct simulations. Normally we conduct 500 simulations or 700 simulations, but sometime when you go for more simulations, computer slow downs. So therefore in this case I'll be using only 100 simulations, but you should practice with 500 and 700 simulations as well. And it's not difficult, because Excel will be doing everything for you. So again, very quickly, we want to do this thing, and these are the formulas that we use. So here's a formula for revenue, which means is equal to price multiplied by minimum of demand and production and number of tailors, and that will give you revenues. And then there's a formula for variable cost. Variable cost, the formula is unit cost multiplied by production, and fixed cost, and then profit. So this is a formula that we will be using here. The very first thing is we have to conduct 100 simulations, as you can see here. So in this column I will fill the series up to 100. So you have a number of options. For example, you can see here 1, 2, 3, and then you can drag it up to here. And one thing that I want to show here is that I have hidden here some columns, as you can see here, 1 2 3 4 5 11 13 14 15, and then after 15 it's 99. So 16 17 and all others, they are hidden, so which means they are hidden from the view, but they are actually here. So I have hidden them here because I want to see everything in one view. So that's one way whereby you can do that. There is another way which I like, is that I will write here one and then again click on one, and then here in home, in this, click on series, and in series click on column, because I want to fill this column, so it's a column. So make sure that you do not select rows but column, and then it says step value is 1 and stop value is 100. I want to fill up to 100, so selecting columns and then 1 to 100, and if I click OK, it will automatically fill it with 100. And again, as I mentioned earlier, that some rows are hidden. You can see here 15 and 99. The rows from 16 to 98 are hidden, but that will not affect our calculation in any way. Okay, the next thing is demand. Now for demand, as you can see, as we mentioned earlier, that demand is normally distributed, and we have been given mean and standard deviation, and the formula for in this case is norm inverse INV, and then the first thing is probability. Now we don't know what's a probability, and we want Excel to generate this probability, and for that purpose we'll use rand function, and this one is rand and then parenthesis, and then you see it suggests me that you need to write here mean. So this is mean, and make sure it's locked by pressing Fn and F4 keys together, and then standard deviation, and here is standard deviation. Again, make sure it will be locked by pressing Fn and F4 keys together. Now that's it. Now before I hit enter, I just want to explain this one more time, that what's the rationale why we are doing this. So the formula for this one is that when something is normally distributed, we don't know what's the probability, because it keeps changing. So because we are conducting an experiment, so for probability we use rand function. Rand will generate probability, and the formula for this one is norm dot INV rand, that represents probability, and then mean and standard deviation. And you see that mean and standard deviation, they are locked by pressing Fn and F4 key, but rand is not, because rand is supposed to be keep changing. It's a random number. So once I hit enter, then I get this one, and then you can drag it down, and here we have demand. Now the next thing is cost. Now as you can see here, cost, again it follows the same pattern. It's normally distributed, and mean is $12 and standard deviation is 1.37. Now I will use again the same formula, because it's normally distributed, and it's usually stated upfront in the a problem. So for example, it says that this is material cost, it's normal distribution, and this is again material cost, it's standard deviation, it's also normal distribution. So for normal distribution, we again use the same approach. That's norm inverse and then rand and parenthesis, and then it says mean. Enter the value of mean. So here's my mean, and make sure it's locked by pressing Fn and F4 key together. And then it says standard deviation, and I will click this one and make sure it's also locked by pressing Fn F4 key. Hit enter, and it says that your cost would be this much. Now again, what's happening here? Now in all these cases, Microsoft Excel is using different values of probability by using rand function, and therefore it is giving us all these different numbers, and the same thing is happening here. So that's why we call it experiment, because every experiment is different. So this is one experiment, this is another experiment, this is another experiment, another experiment. So total we have 100 experiment, and in each experiment we are using a different value of probability. So that comes from this rand function, and that's why we call it an experiment. And you can also see that they're also different, although some of the values they can be same, but in general all of them they tend to be different. The next one is production. So for production, here we have here that's weekly production rate per tailor. It varies from 36 to 41. So, and as you can see here, it says uniform distribution. That is not normal distribution. Please be clear about this one, that it's not normal distribution, which means it varies from 31 to 41. So for this one, we will use this rand between function, and it will be equal to rand between 36 to 41, 36 and 41, and if I hit enter, it gives me this one. No, okay, so that's production. And as you can see here, that all the values are between 36 and 41 using this data. So nothing is less than 36 and nothing is more than 41. Everything is between 36 and 41. Okay, now the last thing, that's one of the most critical thing, that's to calculate profit. And we'll be calculating profit for different tailors, tailor 1, 2, 3, 4, 5 and 6. So for this one, I'll be using this formula to calculate profit. So the first thing will be to calculate our revenues. And for revenue, one of the thing is price, and the price per unit or price per 1 unit of pullover is $50. So, and again, make sure it is locked, because we are gonna drag it down, but this should remain constant. So F1 and F4 key together. Now this one, it needs to be multiplied by how much you are selling. So this is the cost of one pullover, 50, and how many you are selling. But the problem is that sales is unknown. So for this purpose, we will use this command that's called as minimum of these two. That's minimum of your production and demand. So that will give you your revenues. And again, the thing is that why we are using this one, that's minimum of H2 and F2. Now just imagine, let's say in this case, what is the minimum? 36 is smaller, or 129.2 is smaller. 36 is smaller, so which mean they cannot sell more than 36, because only 36 are available. So which mean their actual sale, even that demand is very high, demand is something close to 130, but they can sell only 36 because that is something that's actually available. So therefore their sale in this case could be represented by 36. Okay, now let's imagine another situation. Now hypothetical situation is that, let's say demand becomes 10, only 10, but this remains the same, that is 36. Now this is 10, imagine. Now what would be their sale? Again, the sale would be the minimum of these two. So in that case, the sale would be the minimum, which means 10, because although they have more available, but everything they have made will not be sold because demand is only 10. That's hypothetically, right? So in that case, again, they will be able to sell the minimum of these two. And as I said, that suppose that this is 10, so which means their sale would be considered 10. So that's the whole philosophy, a rationale behind why we use this approach in calculating revenue. And this part so far, that represents our revenue. And as you can see here again, B5 represents our price per unit multiplied by the number you sell, and that whole thing represents revenue. Okay, now I would like to add here just one thing. and that is multiplied by number of tailors, and number of tailors is 1. So multiplying it by 1 doesn't make any difference. Actually, it's a little bit redundant, but I will explain you later why I am adding here. So it means that the production that's carried out by one tailor, because they currently have 6 tailors and we have to find out for 2 tailor, 3, 4, 5 and 6 tailors, and when they have only one tailor, then this would be their a number that would represent sales multiplied by price and unit price, and that would be their revenue. Now from this one we will subtract their cost, and one of the cost is production cost. Now let me put that production cost within brackets so that it appears as a separate chunk of information. So a production cost would be, we know that okay, so this is production cost will be, let's say, H2, and then multiplied by cost per unit, and then because the amount you produce, it depends upon number of tailor. You have one tailor, you will produce less. You have two tailor, you will produce more. You have 6 tailors, you will produce even more. So therefore I will add here the number of tailor multiply. Again, I know it's multiplying by 1 is just redundant, but let's do it for the moment because I will explain it in the next step. And the next stage is labor cost. Okay, so far this part was our revenue, this was our production cost, and now let's talk about labor cost. And labor cost is just one thing, so I don't need to put it in parentheses. Where is the labor cost? Here is the labor cost, $700. So make sure it's locked by pressing F4, and then how many labor, how many tailor, multiplied by 1. Okay, and minus the last, our cost is overhead cost, and that is here, this one, 800. Again, make sure it's locked by pressing F4. And actually over here it's very important to know, to determine which variable, which number should be locked and which one should not be locked. So you can see that all these numbers which are supposed to be constant, they are not gonna change, they will be locked, but other thing they will not be. Okay, so this is our formula for profit, and in this formula, this part, it represents our revenues, which mean the price per one pullover multiplied by the production that you are the sales or something that represents sales, and then this is your cost of production, and then this is your cost of tailors or labor, and this is our overhead cost, and that should give us profit that comes from one tailor because we are using here one. Okay, and if I drag it down, okay, so that gives me this profit, and that comes from tailor 1. Okay, now I want to explain why I was adding here 1. Now the thing is that we have to do the whole thing for 6 tailors. So if you write the same formula 6 times, there is a possibility that you may make some error. So therefore you can just copy this formula and paste it in other cells, and just make sure that only this one would be changed. If you are talking about 2 tailors, replace 1 with 2. If you are talking about 3 tailors, then replace that by 3. If you are talking about 6 tailors, then replace 1 throughout. Everywhere you find 1 here and 1 here and 1 here by 6. So this is the reason I added 1, because it will act as a marker whereby you can quickly change it. So again, you will just copy this formula and you will put it in other cells in this second one. And so for example, I will show you. Now here I have added a formula for Taylor 2, and you see everything is same. The only difference is that this 1 was replaced by 2. It was replaced by 2 and it was replaced by 2. And similarly for Taylor 6, let's say, again exactly the same formula. The only difference is that 1 was replaced by 6. So it makes your life easier. You don't have to type this formula 6 times. You just copy it from Taylor 1 and paste it in the remaining cells, and you just change 1 by 2, 3, 4, 5, 6 depending upon what column it is. Okay, now if I after copy pasting it here, and if I drag it down, it gives me this one. The next thing would be to calculate these averages, and of course we will be calculating averages only for this our profit section, because that's what we are concerned about. No, we don't care about trial, demand, cost and production, or etc. We are only concerned with profit that comes from Taylor. So let's say here is average of this one. Okay, so that's the profit. Now question arises here, you know that we have already hidden some cells here, that's from 16 to 98. Does it affect my average? I mean, am I considering those hidden cells? Yes, they are already being factored in, so you don't have to worry about that. You will have to worry about when we will be making a graph, but for this one it's okay, they are already factored in, so you don't have to worry about that. Okay, and then we also have to calculate other for, but you can just drag it, this one, drag it sideways, and it will give us this one. So as you can see here, this is the average of this column and this is the average of this column, and when you just double click it, it will select that column, which means you are doing it right. So just drag it sideways, and the highest value in this column is max, and select this whole column except the label, and that's it. And again I can drag it sideways, and if you want to check it that is there any error or something, just double click that, and you see that column has been selected, which means only this data is being used. Lowest, for that use minimum, that's min, and again select this whole column except the label, and that will give us minimum value. And again I can drag it sideways, and then the standard deviation is STDEV, selecting the whole column and then pulling it sideways. And no, the last thing is about calculating risk. Now for risk, let me reduce this number of zeros here. Okay, for risk of loss, now this is an important parameter that we need to do here. Now it means that what is the risk of loss? So for example, in these 100 values, and of course we know that some of the rows are hidden, including those hidden rows. Now how many are less than 0? Because less than 0, that would mean a loss, because we are talking about profit. This is profit, and the calculation that we used here is also for profit. So anything that's less than 0, for example this minus 84, that's a loss, minus 93, minus 7, all these negative values, they are a loss, and because they are less than 0. So I want to use here a calculation which means anything less than 0 will be considered as a loss, and for that I will use this function that's called COUNTIF. So COUNTIF, I will be selecting this whole column except the label, and then I say comma less than 0. So it's quote unquote these double inverted commas, and then less than 0. and then close the parentheses and divide by 100. 100 is our number of data points. So before I hit enter, let me explain it one more time. We want to calculate risk, or what is the risk of loss, and for that I use countf function, which means it will count in this whole column the number of values that are less than 0. As you can see, it's represented by this within quotes, that's less than 0, and then I divide by 100 because I want to calculate percentage. So if I hit enter, it gives me 65%, and if it does not give you percentage, you can change from here. So it says that in this case our risk of loss is 65%, and then I'm gonna drag it to the sideways, and here we have everything. No, you have to make a decision. Now, what was our question? Our question was that to address this challenge, it's recommended to conduct 100 simulations to inform your decision-making process on determining the total number of tailors required to maximize your profit. So we have conducted 100 simulations. In other words, we have conducted 100 experiments, and each experiment was different. And why it was different? Because it was using a different value of rand. It was using a different value of probability. So for all these 6 tailors, we have conducted 100 experiment for each tailor. In other words, we have conducted like total 600 experiments. More specifically, let's call it 100 experiment, and every experiment was different, and then based on that we have calculated this number, where this is our risk of loss. And now we have to make a decision, and decision making would be quite easy here. For example, let's say you can see here that in case of tailor 1, risk is 63%. Do you want to proceed in a venture that has 63% risk? No. So this is ruled out. It's out. No way. What about this one? 83% risk. Do you want to proceed with this much risk? No. Out. What about 27? Still too high? No. Out. So which means these 3 options, that's tailor 1, tailor 6 and tailor 5, they are out because risk is too high. And what does it mean that risk is too high? It means that in these cases, in 100 experiments, those number with negatives too much, and we do not want to proceed. So which means there is too much risk, which means our profit, we won't be getting any profit, we'll be risking it's a loss. No, it means no, we have to select from these 3. And but before we select with these 3, I want to tell you one more very important function of this one. Now just press F9 key, or if F9 key does not work, you can press Fn and F9 key. So Fn key, it is almost at the left bottom of your keyboard, and F9 key. So if you press these 2 keys together, let's see what happens. Now I'm gonna press it and see what happens. So you see, when I'm pressing F9 key, all these values, they keep changing, but it's okay, and that's not an issue, and actually we need it because we want to. So it means that we are recalibrating. So F9 essentially means recalibrating. So we are recalibrating, and no matter, if I just consider this one. So for example, I'm gonna press F9. So you see, if I even press it 100 times or 1000 times, it's not changing much. The risk with supplier 1 is 76, 59, 66, 75, 66, 64, 58, 66. So it's not changing much, which means it's not happening that okay, in one time it reduces to 20%. No, that's not happening. Similarly, let's talk about this one. That's 84. Let me highlight it. So this one 84. Okay, let's recalibrate it by pressing F9. Okay, 87, 92, 83, 83, 85, 86, 83. So you see, even if I press it hundreds or thousand times, it's not gonna change much. I mean, again, it's not something that will drop to 20% or maybe even 50%. It will remain very close. And the same thing also applies to this one. And that's Taylor 5. If I again keep pressing, you see it remains very close to that. I mean, sometime it can go to something in 40s, but I see not much change. I mean, it's not going to something 60% or 70%. So that's the whole point. Let me clear it. No fill. Okay. So no, we have to make a decision, and the decision is that as we said, that this one is ruled out because it's too much risk, and these two, they are also ruled out because there is too much risk. We don't want that. Now you have to make a decision from these three. Now, just pause this video for a moment and tell me what would be your decision. Which one you want to go with? Do you want to go with two Taylors? This column represents two Taylor. This column represents three Taylors. This represents four Taylors. So how many Taylors you want to go with? Now maybe your answer could be that 3 or 4, and maybe you may wish to exclude this one because it's 1% and it's still some risk, but over here there is no risk. But it's a little bit tricky. Tricky in the sense that although there is a little bit risk, but profit is also very high here compared to this one. So for example, let's say if we talk about this one, that's profit 3, profit from two Taylors, as you can see here. Now in this case, although risk is 0, which is a very good thing, but profit is also very low. That's only 717, and compared to this one, where although risk is again 0, but profit is almost double. So which means that this one again is not a very good choice. Although risk is 0, but profit is not very high, so I'm gonna exclude it. So I will exclude this. Okay, now we are left with two options here. Now which option would you choose? Would you choose 3 Taylors or would you choose 4 Taylors? And again, it's a tricky decision whereby there may not be a correct answer. You may use your discretion, and that would be perfectly okay. But let's go for this one, and over here you can see this one has more profit compared to this one. Let me recalibrate it, and let's see what happens if we press it. No, I'm gonna press F9 key again, Fn and F9 key together. So it looks like that in most of the cases F3 has more profit and risk remains 0 compared to F4, which although in some cases has more profit but risk also remains. For example, sometimes it's 4, 5 or 1, or here it's even 6. So I think again, now we know what to do. Now when we are comparing our profit and risk, it looks like Taylor 3 is perhaps a better option. So I would like to exclude this one also, which means it's okay, but not a very good choice. So I would go for this one, which means we go with 3 Taylors. So this column, a profit from 3 Taylors, because this is the one that gives us 0 risk and substantial profit. So that's our decision. Now there's one more thing, and that's making a graph, a scatter plot. Now for scatter plot, we will have to expand those hidden rows. We need to make them visible, otherwise our scatter plot will not be a good one, and I will show you why. So let's go And I want to make a scatter plot of only 3 and 4. I mean, we don't need the scatter plot of others, because that is purely loss. 1, 2, 5 and 6, they are only loss. So I'll be making a scatter plot of only Taylor 3 and Taylor 4. Okay, so let's go with this one, and I will select these columns, and I will click on recommended charts, and then here is a scatter plot. And this is scatter plot. Again, it's not a good one. As you can see here, there are only very few points, because it's, again, the rows that are hidden, they are not being displayed here. So for this one, we need to unhide those rows. Unhide it first. So just click on, this is how you hide and unhide. So you click on those two rows, which mean 15 and 99, that the rows between them are hidden. So I select 15 and 99, and then or right click and then unhide. So this is unhide, and if you unhide, you see all those they become visible. So here we have all those data, as you can see here, 100 rows. Okay, I will select these two columns, and then go to insert, and in insert I will click on, let's say, scatter plot, and this is our scatter plot. And now you can see there are more data points here. Okay, now here, this is we need to refine it. It's not a good one. It's a defective one. So what I want is that I want the points, all these data points that you can see in purple color and blue color, to be here. So which means I want data for 3 tailors, and I data for 4 tailors here. So for that purpose, click on right click here and select data, and here okay, so let me call it, it's already 4 tailors. And x value, what's x value? X value is that this is number of simulations. So this is the one that we are going to use. We didn't use it earlier. That's the trial. So I want it to be x axis, and then in y I want to use data for Taylor 3 from here, and I will select this whole column, and you can press Ctrl Shift and low arrow, and the whole column will be selected. And because I'm using 3, so I'll use here 3 tailors, and I will click OK. And now I will make another one whereby I will add 4th tailor as well. Again, click on select data, and I will add here, and let me call it Taylor 4, or 4 tailors. And what's x? X is, again, that's number of simulations. That's this one. And again, you can just click on Control Shift low arrow key, and the whole column will be selected. And then y will be the data for 4 tailors, that is in this column number L. So I will select Control Shift and low arrow key, the whole column is selected, and if I click on OK, now we have this one. So here we have a beautiful scatter plot, but we still need to refine it. So one thing that I want to refine it, you see here, why is this empty? Well, of course, this is number of simulations, 0, 20, 40, 60, 80, 100. We did 100 simulations. So why it is 120? I don't want that. So I want to cut it up to 100, because there is no data point, and there cannot be any data point, because we only conducted 100 simulations. So we don't need 120. So I will double click on this one, and it says maximum. It says 120. I will change it to 100. Okay, and that's much better. Another thing, we need to add legends and title. So click on chart design, and this is something that can be different in Windows and MacBook, but I'm sure you will easily figure out. So if you are using a MacBook, then add here legends from this one. I'm sure in window it will be a different path, but it will be easier. So I want these legends to appear at the bottom, so I click here bottom, which means I want to see what does this orange data represents and what does this blue data represents. That will be legends. So, and I want it to appear at the bottom. So when I click at the bottom, it says that blue data points represent 3 tailors and orange data points represent 4 tailor. And the next thing is that I also want a title. So here is chart title I want above chart, and that would be a comparison of 3 and 4 tailors. Okay, we are almost done. Now one more thing that you can do, again it's all aesthetics. Maybe for example you can change the layout or pattern. I mean, you can click on this one if you like it, maybe this one. Well, it's your choice. You can choose any design from here. Now again we need to make a decision here. I mean, although we have already made a decision that we need 3 tailors, but this part is going to support our decision making. Now for example, again if I press F9 key, which means that's recalibration, which means pressing Fn and F9 keys together, then this graph scatter plot will also change. So you see it's also changing. Okay, now what type of information this is giving? Well, it looks like that there is one thing that's very conspicuous in this scatter plot, and that information is that when you look at these orange data points, they are pretty much more scattered. I mean, you won't see here any blue point. You will see only orange data point here. You will see here only orange data point and no blue. Blues are mostly concentrated in this area, somewhere in the center, somewhere close to 1500, or you can say somewhere between 1000 and 2000. So blue data points are concentrated between 1000 and 2000, but oranges are more distributed, so which means that there is more deviation in orange data points and less deviation in blue data points. In other words, it also means that blue, which represents 3 tailors, the profit with this one are more consistent and there is less variation, which means there's a greater likelihood that you will get these results more consistently. 4 is also okay, but there is more spread. I can see here, I mean here in this range and also in this area, and that much standard deviation is not desirable. So again, this scatter plot shows that our decision to go with 3 tailors was a right decision. So now here is our final decision. Our final decision is that based on this plot that we have made here, and again remember that whenever you are gonna make this scatter plot, you need to unhide those rows, because if those rows are hidden, this scatter plot won't be clear. So based on this scatter plot and the one we have here, it is clear that we need to go for 3 tailors. So that's all about simulation, and if I can recapitulate everything very quickly, I would say that in this case we conducted 100 experiments, although we should conduct maybe 500, at least 500 or 700 experiments, but for this one I only conducted 100 experiments. And in those 100 experiments, every time we used a different value of probability. So you see here this rand function. So every time we are using a different value of probability. So therefore all they are distinct experiments, and based on that we made this decision.